Hi there, we are starting chapter or unit 3 on measurement. And we're going to start on the first part, which is the metric system. Hopefully you've all got the booklet. If not, you can go on Brightspace. And if it's not there right now, it will be there this afternoon. So this is Workplace and Apprenticeship Math 10 and the metric system. The nicest thing about the metric system is it is based on, sorry, just moving my stuff around here so I can see better. Based on multiples of 10. Unlike the imperial system, where you have to multiply sometimes by 12 and sometimes by 3 and sometimes by 5,280, I think that's the number of feet in a mile. Everything is based on 10. So that since the 1960s, the International System of Units, or SI, is the internationally recognized metric system. The only country, there's about 2 or 3 countries left that don't use the metric system. Hey, Corey, do you know what one of them is? Yes. I don't know if Mike picked that up, but yeah, US. And I want to say Libya might be one more, and there might be a third country, but the big one is the United States. And you can see here we have a list. What we've done in class is we've concentrated from kilo to milli. But I just wanted you to know that there's more than that. The nice part here is we go 10, hundreds, thousands, so it's always a step of 10. But from the thousands to here, you'd actually take 3 steps to get to mega. So our whole nice pattern of the number of steps is the number of decimal places to use kind of falls apart. But you've got mega and giga and tera. I'm old enough to remember when megabyte was a cool thing. If you could get a thumb drive or a CD or something that held that, mega was pretty cool. And now they're up to terabytes. And you can also go the other direction where you go micro, nano, and pico, 1 millionth, 1 billionth, and 1 trillionth. Okay, but we are really just going to concern ourselves from kilo to milli. That's the most common stuff that we're going to see. All right, so here's the units. I would ask, now that we're in math class, and this is the second time we've done it, it's time you memorize that order. And I've seen lots of memory tricks over the years, and I finally one year had my students do it. And they came up with cook 'em, had dinner, but didn't cook much. One person changed that to cook 'em, had dinner, but didn't call mushroom, but we thought that was too mean. So there's your mnemonic to remember the order of them. Okay. A couple other things that we've talked about in science already. Okay, count your steps. Decimal moves same number of steps in the same direction. If there's no decimal, you can always put it at the end of the number. And this is the one that messes up people. Is the difference between, if it's just a single M, it's millimeter, it's meter. 2 M's, 2 little M's is millimeter. And not that you ever see it very often, but a capital M and a little m is megameter. And for anybody that's noticed my hand, I sculpted it, so yeah, it looks goofy. Sorry. All right, end of the page. Reference is something we didn't talk about in science, and they're really important. Because there's nothing funnier, nothing funnier to a teacher than a student that tells you they're 1.4 centimeters tall, and it's like, no, you're not. I don't know what you are, but you are not. So you need to know the references. So the thickness of a paperclip or the thickness of a dime is a millimeter. Hey, Corey, where are the millimeters on a ruler? What are you looking at? He's checking it out for me. Yes, and they're he's showing me the teeny tiny ticks. Okay, thank you. You didn't know you were co-starring in this video, did you? Okay, the width of your pinky finger. Oh my goodness, it looks really fat today. is basically a centimeter, and the length of a pace is a meter, but the length from your nose to the end of your fingers is going to be pretty close. Now, with every system, we have the base units, and the most common ones that we have to worry about is going to be the meter, the gram, and the liter. Degrees Celsius is the metric system, but you don't talk about millicentiuses, millidegrees, or something like that, at least not normally. I've done science for a whole lot of years. I've never seen that. So again, it's going to be these top ones that we worry about. All right, so first of all, we're going to use this reference stuff. Choose the most sensible. So the length of a pencil is at 8.5 millimeters, 8.5 centimeters, meters, or kilometers. Now, hold on, I just found a ruler. All right, so first of all, there's a mistake on a ruler. Those should not be two capital M's. It should be two little m's, because these are millimeters. So a millimeter is the distance between there and there, all of those little ticks. So again, hey Corey, which one of those, A, B, C, or D, is the best choice for the length of a pencil? All right, so I disagree. That means your pencil is exactly that long. No, wait a minute, 8.5 millimeters would be starting here and would be about that long. So that is about 8.5 millimeters. That's too short. But if we go 8.5 centimeters, that's about that long. Now, this is a wonky ruler. Oh, I said wonky on the video, sorry. Because it goes by millimeters. Most rulers will go by centimeters. 8.5 meters, Corey, do you know how long that would be? 85 millimeters, 8.5 centimeters, but we went to 8.5 meters, that's like down the hallway. So that's no good. And 8.5 kilometers is probably like across Regina, or at least cross part of Regina. So keep your reference in mind. Think of the millimeter. This is the thickness of a dime, thickness of a pinky, arm's length, and a kilometer is 0.6 of a mile, if that helps. So it's a fair distance. All right, so length of a desk. Take a look at that and see what you guys can come up with. All right, Corey, picking on you. What do you think? Perfect. 160 centimeters. Okay, 16 millimeters, sorry, 160 millimeters would be from there to there. That's way too small for my desk. It's smaller than a piece of paper. So 160 centimeters is a good choice. And so is this one. All right, now let's use converting these measurements. There's so many ways to do it, but I'm going to show you the way that I've developed. I can't remember. It might have been a student that taught me this. And it works like a charm. If you went to a different school and you've got like how Sass Poly does it or someplace else, and you always get the right answer, I'm okay. You don't have to do it my way. So the first thing I want to do, kilo, hecto, deca, base, deci, centi, milli. And I rewrite that all the time. So what we want to go is from kilometers to meters. So we start at kilometer or kilo. Now, which M is this one, Corey? Where? Yeah, it's meters. So where is that on my chart? Perfect. Exactly. Remember this base? That can be meters or grams or liters. A single letter is going to be your base. So we need to go 1 2, 3 steps. So we take our decimal place, which I'm going to put in there, right? If there's no decimal, you put it at the end, and you need to go 1, 2, 3 steps. And you always take your steps in the same number and the same direction as you did steps on the chart. So my decimal place is going to move to over here. So I'm going to have 56, and all of these loops get zeros. You're going to get 56,000. Okay. So from kilometers to millimeters. Oh, I shouldn't have done that in pencil. Well, I guess we'll just erase it. Whoops, so sorry. I'm going from kilometers to millimeters. So that's going to be 1, 2, 3, 4, 5, 6 steps. So I take my decimal. I'm going to go 1, 2, 3, 4, 5, 6. And everywhere that there's a loop, I'm going to put in a 0. So I got 1, 2, 3, 4, 5. 1, 2, 3, 4. Ah, last one. There we go. So what I want you to do right now is I want you to pause the video. I'm going to try and pause it too and do those next 2 questions. Okay, and we're back. Let's see about these new ones. Now we're going from centimeters to kilometers. I'm going to go underneath here. So we got to start here at centi. I got to go all the way to killi. So 1, 2, 3, 4, 5 steps. So I'm going to start at the back. I'm going to write it down here. You don't have to rewrite it. I'm just, my writing is bad to begin with, and this messed up hand doesn't help me. So I need to go 5 steps left. So there's 1 step, 2 steps, 3, and I need 2 more, 4, 5. My decimal is going to end there. And just like before, those empty spots get zeros. Those act as placeholders. And I'm very fussy. I want 0.00360. Can be really honest. I'm getting old and I don't want to buy new glasses. So please don't do this. Well, you can see that one, but I have students where I have to like almost squint and hold it up to the light to see if there's a decimal in there. Humor your teacher, put it nice and big and put a 0 out front. If you want, this 0 right here actually isn't doing anything. It's not specifically a placeholder. If you drop it, it's fine. It doesn't matter at all. But if you're not sure if you should drop it or not, just leave it there because it doesn't hurt anything. And some zeros at the back after the decimal are going to be really important in university or grade 12 physics or grade 12 chemistry when you talk about significant figures. For here, not so much. All right, we're going to go from meters to kilometers. So meters is going to be in the middle. Remember, a single letter. So it's going to be 1, 2, 3 steps. So I start at my decimal. 1, 2, 3 steps. So I'm going to fill in that front loop with a 0 out front. How'd you do? You got them? Perfect. All right. So a couple of pages from now, there's a bunch of practice. But I want to do some of the questions. And then I'll point you towards the practice. Okay. These guys, I borrowed this from a friend of mine. These questions get sneaky right away. Imagine I gave you a $5 bill. Okay, so don't worry about this. I gave you a $5 bill and 3 toonies. Okay, if I gave you that, hey, Corey, how much money did I give you? $11. That's awesome. But if you've ever dealt with a little kid, you can always give them lots of coins and they don't understand, they're happy. You could give them a handful of dimes and they're like, woohoo, I got lots and lots of money. They have to be converted to the same units. And even without any pre-prompting, Corey did exactly what I was hoping for. Actually, I didn't even know I was hoping for it. If you have different units, if you convert to the smallest one, it usually works the best. So where am I going with this? Look, here's where the question is tricky. We got 1.2 meters there. You really have to pay attention to the units in this section. And you got 20 centimeters. You can't do the question right now. You either have to convert everything to meters or everything to centimeters. And I find if I convert to the smaller of the two units, the math is prettier. There's not some, it just works better. There's not as many weird things going on. I'll show you what I mean. I'll actually do this question both ways, but I'm hoping you'll adopt my plan of always converted to the small. So first thing we want to do, I'm going to label this convert to smaller unit. And I guess this is where our reference comes back in, because we have to remember that the centimeters is a smaller one. So 1.2 meters is equal to some centimeters. So do that conversion. So from meters to centimeters, meters is our base. So that's 1, 2 steps, 1, 2 steps. So that should be 120 centimeters. Cool. Yeah, well, you can't use that come exam, but you certainly can when you're checking. So we need, okay, now we can do the question. A tree house is 1.2 meters high. If each step is 20 centimeters high, will 7 steps reach the house? Oh, I guess there's at least 2 different ways to do this. You got some ideas? What do you want to do, Corey? Well, we can do it one of 2 ways. We could start with saying, I have 120 centimeters to go, and I'm going to divide that by 20 and see how many steps I need. So that's going to be 6. So it looks like 7 steps is going to reach it. I wrote that over there because there's another way to think about it. You could take the fact that you have 7 steps. Each one is 20 centimeters. And that would give you 140 centimeters. So then you could say, well, 7 steps is going to take me that. I only needed to go 120. Either way, 7 steps is more than enough. So that's one option. If you want to convert to the bigger unit, I'm going to take my 20 centimeters and I'm going to convert it to meters. So this time I'm starting at centimeters and I'm going to go 1, 2 steps. So I'm at my back, I'm going to go 1, 2 steps. So 0.20 meters. And then the process is the same, except I'm going to start at 1.2 meters, divide by 0.2 meters, and I'm still going to get 6 steps. So the process is exactly the same. I just find that if I work with the smaller numbers, I don't have decimals to worry about. It's a thought. All right, so now on your own, I'm going to pause the video. I would like you to pause the video. Try, there we go. And I would like you to do the next question. All right, welcome back. Let's take a look at this question. I was doing it with a student who is here, and we came up with two different answers. They're both correct. And that's kind of cool that there is multiple ways to do this one question. But the first thing that we both did is we converted everything into centimeters. Again, we've got this craziness. Well, it's the point of the question. We've got meters there and centimeters there. And I'm only going to do it once. I'm always just going to convert to the smaller unit. If you want to convert to the big one, you go ahead. That's fine. Your answers are going to be the same. So I've got 0.5 meters equals how many centimeters? Now, if I'm going from meters, center, my base, to centimeters, 1, 2 steps. I'm going to go 1, 2. And I'm going to put a 0 in that spot. So the answer is 50. Some students I've seen over the years are too cool to draw the loops. And you know what those students are? Those are the ones that tend to make mistakes when they're doing the metric system. Be loopy, just like your instructor. Please draw them, you'll be more successful. Okay, so there's two ways to think about this. This is the way I thought of it. Is we've got this pile of tiles. No, sorry, a stack of tiles. And that stack is 0.5 meters high, which I've now converted to 50 centimeters. Okay, so this is our tiles. And each one of the tiles is 1.2 centimeters thick. So there's my first tile, and that's 1.2 centimeters. And there's the second one, and it is also 1.2 centimeters. Now, Nora needs 35. So I need to know how many of these 1.2 centimeter tiles are in that pile. So I thought of it in terms of the whole thing is 50 centimeters. And I'm going to divide that by 1.2 to see how many are in the pile. And if I do that, 50 divided by 1.2, I'm going to get 41.6. So that's going to equal 41, whoopsies, got my decimal in the wrong spot. 1.6 tiles. So let's see, 42 tiles, close enough. And she only needed 35. So she has enough tiles. She only needed 35, and our pile has like 42 in there. So we're good. But another way to look at it, same idea, is you could say, well, I need 35 tiles. How tall is that pile? So I can go 35 times 1.2, because each one of them is 1.2 centimeters thick. 35 times 1.2, and that works out to be 42 centimeters. So 42 centimeters is 35 tiles. I have 50 centimeters, so I have enough. So 35 tiles are 42 centimeters tall. So 50 centimeters is more than enough. Oopsies. And there you go. both of those answers are right. I'll accept both, whichever way you do it. And it was just a weird thing that this was 42 tiles and that was 42 centimeters. That isn't always going to happen. So there's lots of ways, different ways, approaches to this. I'm a visual learner, so I often will draw myself a picture first. I'm going to ask you to do the next question. However, I realize now it's really hard to see, so that we all agree here. That says 28 meters, and that one are both 5 meters. All right, so I challenge you again. Stop the video, do the question, and then turn it back on and see if we agree. Hi there, and we're back. Hold on, I can do this now. All right, so example number 4. Notice, I'm sure you got this. How many meters of lights will he need? Well, he needs to have lights along the peak and all the edges. I hope you all knew that peak meant this part here. Okay, so he's got to have lights along this long edge and this edge and this edge. And each one of those is going to be 28 meters. So there's a number of ways we can do this. We could just go 28 plus 28 plus 28. That's this one and this one and this one. And then we've got a 5 here and a 5 there. And I'm going to assume that the building is square, and a 5 here and a 5 here. And that should give us our answer. 28 plus 28 plus 28 plus 5 plus 5 plus 5 plus 5. Ah! And I got syntax error. 28 plus 28, 28 plus 5 plus 5 plus 5 plus 5. 104 meters. It's really important, excuse me, in this unit to remember to put your units in there. 104, whoopsies, I forgot my 4. I got my unit, I got a little excited there. That's one way to do it. If you want, you could do it a little bit faster, and you could go 3 times 28 plus 4 times 5. And if you do that, you're still going to get 104 meters. It makes no difference to me which way you do it, but please show me your work. I don't want just a final answer of 104, because if you mess up and it's 103 and all you give me is the answer of 103, you get nothing. I can't give you any work for marks for your work. And then there's my little rant for today. We need to express that in centimeters. So 104 meters is equal to centimeters. Oh, my chart's up at the top. So cookum, had dinner, but didn't cook much. So I'm going from meters, which is my base, to centimeters. 1, 2 steps. So my decimal is there. Remember, if there is no decimal, you can just add 1. 1 loop, 2 steps. So 10400. So 10,400 centimeters. Cool, cool. All right. Now, I'm going to challenge you, take a break and turn the page over and do those questions. Please. Okay. I'm going to do them. So hopefully we're going to have the same answers. And I'm going to be really honest. I haven't done a lot of videos for grade 10. So I'm going to do my other little rant today. Sitting there and watching me do the video and just copying it. I mean, it's better than not doing it, but you need to do it alone, because at some point you're going to have a hand-in assignment that you have to do. And if all you've done is follow the videos, it's going to be might be scary. And definitely you're going to have a test coming up where you're going to have to be able to do this independently. So even if you make a mistake, do the questions on your own in pencil, and then you can make corrections when you watch the video. There's also should be, I guess I'll be posting an answer key on Brightspace, so you can take a look there. All right, so there's the end of my little rant. Let's take a look. Lois wants to send a box of oranges to a friend by mail. A box of oranges cannot exceed a mass of 10 kilograms. If each orange has a mass of 200 grams, what is the maximum number she can send? Okay, they've got mismatched units again. We got 10 kilograms and we got 200 grams. Which one is smaller? That's the 200 grams. Remember on the cook 'em, had dinner, but didn't cook much. This is the biggest unit, and this is the smallest. So if you want the ones that are furthest to the right, for me, that's what I'm going to convert to. Anyway, I'm going to convert to grams. So 10 kilograms is equal to how many grams? But wait, there's no G on there. Remember, single letters. This is meters and grams and liters. So I'm going from kilograms to grams. So 1, 2, 3 steps. So I start at 10, and I'm going to go 1, 2, 3 steps. That looks horrible. Okay, so I'm here. I'm going to go 1, 2, 3. Boop, boop, boop. And I'm going to get 10,000 grams. And that's sort of why they have kilograms, because grams are really small. They're, I want to say, about the mass of a dime or something like that. So instead of using really big numbers, you just convert it to a bigger unit. It's like, you know, imagine that you got paid in dimes. I was going to say pennies, but those are, we don't have those anymore, right? You don't want that. You want bigger units. Sorry, ranting a lot today. So we've got 10,000 grams, and we're going to divide that by each orange is 200 grams. One, 2, 3. Divide by 200. And the answer is 50 oranges. So she can send 50 oranges. We really want to get fancy. Nope, I'm not going to get fancy. There we go. There's our mouth. Example number 6. Walt grew 10 centimeters in a year. He is now, oh, here we go, mismatched units again. But I mean, that's the point. They're trying to get you to practice converting. 10 centimeters in 1 year. He's now 1.6 meters tall. How tall was he a year ago? So I'm going to take my 1.6 meters and I'm going to convert it into centimeters. So from meters, which is a base, to centimeters, it's 1, 2 steps. So I'm going to go 1, 2 steps. So that first step takes me to the back of the 6, and then I need 1 more. So this is going to give me 160 centimeters. Now it says right now he's 160. So I'm going to write that. How tall was he a year ago? Well, you know what? If you're having a really bad day and not sure what to do, you could probably do addition, subtraction, multiplication, and division, and only one of those is going to make sense. But I think you've got this figured out already. So 160 centimeters minus 10 centimeters, because that's the amount he grew, is 150 centimeters. And since the question didn't tell me what units they wanted it in, 150 is fine. If they wanted it in meters, then you would just move it 2 decimal points and you'd have 1.5 meters. All right, next one. Carlos has a wood that is 1.2 meters long. He wants to cut it into 3 equal lengths. How long should each piece be in millimeters? Okay, here we go. We got meters and millimeters. So I'm going to start by converting this into millimeters. That's my first step all the time. 1.2 meters. I'm going to move my screen here. All right, so 1.2 meters. So there's my base. And I'm going to go to millimeters. So 1, 2, 3 steps. So I got 1.2. I'm going to put it down here. I'm going to go 1 step, 2 steps, 3 steps. And again, those end up with zeros. So 1,200 millimeters. All right, I want to divide that into 3 equal lengths. So I'm going to go 1,200 divide by 3. And that's going to give me 400 millimeters. And there we go. I once had a student who was from the country Chile, which is in South America. And I was actually tutoring him in fractions because he was in carpentry and he could not for the life of him understand why North Americans were using feet and inches and 1/16 of an inch and all of that stuff when you could just simply do it in millimeters, which makes life so much simpler. Just saying. All right, well, let's see. We got stuff on the next page. Nope, that's as far as we're going today. Okay, that is the end of the video. And tomorrow, nope, Monday, we are going to look at the next section and we'll be done the chunk on the metrics. Thank you and have a lovely day.